the last class we have done the tabulation, right? So I will give you some example of this tabulation. In the last class we have done this, right? Is that clear? Hello?
Yes, sir.
Yes, sir.
Do you remember this question or what?
Yes, sir.
Is that clear? Can you do the similar example? Can you do the similar example? Yes, please tell me.
We can try, sir.
Okay, see in example 3.13. Do this one. Only 5 minutes. Done? Done or not? Please tell me. Are you doing? Hello?
Yes, sir. Can you give me 5 minutes more, please?
Okay. Yes. Done or not? Can I do? Hello. Can I?
Yes, sir. I've done for town A. I've completed.
Town A completed. Yes, any other? Divya,
No, sir.
have you tried this or not?
Yes, I tried, but I couldn't.
Now see the answer. See. In this example, in a sample study about coffee habits in two towns, the following information was received. Town A, females were 40%, total coffee drinkers were 45%, right? And males, non-coffee drinkers were 20%. Similarly, for the town B, males were 55%, males, non-coffee drinkers were 30%, and females, coffee drinkers were 15%. So what you have seen in this, one, first of all, town A and town B, right? In the similar way here, 1995, that is town A, 2000 town B, in the similar way, right? Male, female, similarly male, female, right? Now, other thing is what? Coffee drinkers and non-coffee drinkers. Made the similar to this, see. For the town A, males, females, coffee drinkers, non-coffee drinkers, right? Now, see, first one. Town A, females were 40%. See, town A, females, 40%, right? Okay. Now, the grand total of all these are 100% because percentage always take 100. So the total one is, grand total one is 100. Okay. Now, total coffee drinkers were 45%. Coffee drinkers were 45%. Fine. So we subtract 100 minus 45, we got 55 this. Okay. Now, males, non-coffee drinkers were 20%. Male, non-coffee drinkers are 20%. We got this 55. So 55 minus 20, 35, 35 here. Right? Similarly, this one is 40% females. So 100 minus 40, 60 is females. 60 minus 20, coffee drinkers male, 40. Similarly, this is 35, so 40 minus 35, 5. In the similar way, for town B, see town B, males were 55, total males were 55. Total is 100% already given. So 100 minus 55, we got 55, 45% of females. Got it? Next, males, non-coffee drinkers are 30%. Male, non-coffee drinkers, 30%. We already have this 55, 55 minus 30, we got this 25. Right? And females, coffee drinkers were 15%. Female coffee drinkers were 15%. Female coffee drinkers were 15%, right? So we got this 45, 45 minus 15, we got this 30. Right? Similarly, 25 plus 15, we got 40, 30 plus 30, we got 60. That's it. Right? This is the single table. Is that clear?
Yes, sir.
Yes, sir.
Okay. Now we do how to show data, that is the frequency distribution, how we make the frequency distribution. Generally, when we do the calculation, right, we have two types of data, right? One is ungrouped, second one is group data. Ungrouped and group data, right? Ungrouped is what? Yes, ungroup is what? For example, in a class, there are 10 students, right? 10 students. So what I took the test of all the 10 students, right? So in my hand, there are answer sheets of all 10 students. Hmm. So let me take an example of this class, right? So I have answer sheet of Abhishek, Akshay, Dinesh, Divya, Tanveer, Nancy, right? So that means ungroup because I have data of all the individual students or person, right? That means Abhishek is an individual entity, right? So I called him Abhishek, please. This is your answer sheet. So that is an individual thing or ungrouped thing. That is a single thing, right? So the single cluster of these are called the ungroup, or we say individual, right? So generally in the stats, we have two types of data. One is ungroup, or we say individual series, and the second one is group data. In the group data, there are two types of further we divide group into two further series. One is a discrete series and the continuous series. Right. Now, individual ungroup is clear. There is anything to show you this. I'll show you the simple live example of your class, right? This is we call the individual series. Okay. Now come to the group series. What is the group series? Group series. Now, right now in this class here, there are 6 students, right? I have the answer sheet of 6 students. I can remember the names of all the 6, and as well as I can discuss anything, or I can find out the result, or whatever the result I need from those data. Those data means I have the class mark of all the 6 students, right? So I can easily find out the mean, average, median, or whatever I want, who got the maximum marks, who got the minimum marks, what are the average marks every student's got, right? This can easily be calculated, right? When this class become of 100 students, right? In that case, or let me take 50 students, right? Now, in the class of 50, it is not an easy job to find out the average of all, right? Or any other calculation I need. For instance, I need the median or the quartiles that we do later on. So I need to find out these things, median or average, mean, right? So it is not easy job that I can add all the marks of 50 students, then divide by this to get the average, right? So what we do, we align or arrange those 50 students into groups, right? For example, I took the test out of 20 marks, right? So most of the student got either 16, 17, 18, or 19 and 20. That's it, right? So all the students got from 16 marks to 20 marks. So what I do, I do marks, I do one column, make a one column and write the marks like 16, 17, 18, 19, 20. This 20 marks, right? So how many got the 16 marks? I counted that 7 students got the 16 marks. So I write 7 over there. Similarly, how many got the 17 marks? For example, 12 students got this. So I write 12. Right? So similarly all. Right? So the number of students should be, if we add all the number of students, the total should be 50 because there are 50 students in that class. Got it? So this kind of what we have done, we done individual series of kind of data into group, ungroup into group, right? So in that group, the long calculation become short because we can easily, with that representation, we can easily see how many students got the 16 marks, how many got the 17 marks, and so on like this, right? This is clear. Now, on the basis of that result, I can find out, yes, what are the average students, how many average students got this, and all this blah, 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 right? So with the help of that representation, I can find out the good result, right? So this type of data, this type of data is called discrete series, right? This is in the group distribution, discrete series, right? Okay. Now, in the similar way, let me assume I took the test out of 100, right? So there is much possibility that student got, I assume that all the students got more than 65, and that is minimum one is 65, and assume that maximum is 95, right? So all the students got marks between 65 and 95, right? Now, in this case, some students got 65, some 66, some 71, some 72, some 73, some 81, some 89, some 88, some 91, some 69, and so on like this, right? So in this exam, in this type, it is not possible that I can write all the marks in the first column, the number of students, because there are only one student who got 65 marks, and there are only one student who got 95 marks. Some students got 60, 2 students got 66, 5 students got 69, 3 students got 70, and like this. So it is not an easy job for tutors. In this case, what we do, we made some intervals, right? We made some intervals. In that intervals, we divide that marks into the intervals. For example, I know that because I knew that most of the students got the between 65 to 95. So I made an interval of the 5. For example, 65 to 70, 70 to 75, 75 to 80, 80 to 85, 85 to 90, 90 to 95, like this. Right? So between 60 to 70, how many students got? I write this. Yes. 8 students got marks. Similarly, between 70 to 75, there are 7 students. Then 75 to 80, Hello. Hello.
Yes, sir.
Yeah. Okay. Is this clear? Right. So I made I made some intervals. Audible.
Yes, sir.
Now, this classification on the basis of criteria, the data are classified according to depends on the objective and the purpose. For example, geographical, area-wise, chronological, qualitative, quantitative. For example, in this geographical, this is example of geographical classification, right? For example, in the first column, we write the country, second one is average output, Indian average output is USA, Pakistan, and so on. This is the what we made this table on the basis of geography, right? That means locality wise, area wise, something like this. Chronological means this in the series, maybe descending or ascending, whatever we make series. For example, in the year in 1901, the population was this, in 1911, the population, and so on like this. Okay. Qualitative classification. Qualitative classification is when the data are classified according to some quality, like honors, beauty, employment, intelligence, occupations, and all these things, right? For example, this population, we divide further population into the genus highly intelligent, average intelligent, below average, dull, or further, if we further divide into the this male, female, right? So further male, female, then smokers, non-smokers, in female smokers, non-smoker. Further smoker, Hindu, non-Hindu, non-smoker, Hindu, non, and so on. This is the classification. Oh, sorry, quantitative, qualitative classification. Now comes to the quantitative class. Quantity means which depends on the quantity. Which I already discussed this example, right? And this, for example, this up to 100 number of stores are 6. 1001 to 200, the daily earning. This is given the daily earning in 100 rupees of the 60 departmental stores. So this is given earning up to 100 rupees. That means 1000. There are 6 stores. Similarly, sorry, this is up to 10,000. Sorry, then 10,001 to 20,040, and so on like this, right? And this the first one, the first column. This the first column is daily earning, right? Now, this is called the variable, the first column, right? Variable, that means who vary, right? So, whatever we need to calculate, either mean, median, or any statistic calculation we need, we have find the result only for that variable, right? If we calculating the mean, right? So mean is what? Sorry. Mean is what? We have to find the mean of daily earning, right? Not the number of stores, right? So this is the variable which vary. I already told that there is 2 type of variables, continuous and discrete series. I've already discussed. Now come to this frequency distribution. What is that? See, let us consider the following distribution of the 200 students in an examination, kindly serially in the order of their roll number, right? These are the marks of 200 students, right? For example, roll number 1 got this, 2, 3, 4, 5, and so on. They got these marks, right? Now, see, right? Roll number 1 got 70, then 45, 33, 64, 50, 25, and so on, right? Now, this is called the raw data or disorganized data, right? So, in the raw data or unwidely in the scattered, even after the very careful procedure, the various data will contain the remain unfollowed composite. In general, we cannot found any fruitful result from raw data, right? What we do, we arrange in some other form that is called the array data, array, right? So we arrange this data in some particular pattern so that we can easily find out the result, right? That is a discrete and continuous series, which I've already told you. Now, in this, we found that they got 15 marks to 78 marks. They write out the number 15, 16, and so on up to 78, right? Right. In the discrete series. This is better if we do in the continuous series, but let's find out the difference why we need the continuous series and why the discrete series. See, in this, we know that with the first look, we have found that the minimum marks is 15 and the maximum marks is 78, right? So now we write all the 15, 16, 17, 18 up to 78. Now come to the first. The first one is 70, right? Now 70 is here. This is 70. What we do, we make one bar, one straight line, right? This is called a bar. This column we call the tally bars, right? So we make one tally bar here. Similarly, the next one is 45. So in the 45, we make another tally bar and so on like this, right? So after making all the tally bars, see, in this, for example, in this 17 wala, right? We have seen this 1, 2, 3, 4, right? 4. For the fifth one, we make this kind of cross line, right? So this is kind of called the bundle. So this is a bundle of 5. So we write 5. Similarly, see here in the 42 wala. 1, 2, 3, 4, then cross line, 1, 2, 3, 4, cross line, then 4. So how many this? 5, 5, 10, and 4, 14. So after this, we calculate all these numbers, and these numbers are called frequency. These are called frequency. Okay. Is that clear, beta?
Yes, sir.
Now, see, so in this example, we made 15 to 78. So long distribution table, right? So the better way, we divide further into this intervals. That is a better way. And that is called the continuous series, right? This kind of series is called the discrete, and that is called the continuous series. Now come to the continuous series. See, right? This is a continuous series, right? So what we do in the continuous series, we make the intervals, right? The first one is the marks, the number of students, the similar with the frequency and all this. In this example, what he wrote 15 to 19, he skipped the telemark. The similar way what we do for this discrete series. The first one, for example, the first one is the 70. So what we do in the telemarks, we in this 70 to 74, we make the telemark here, right? Similarly, the next one is 45. We make telemark here, and all this similar to it, right? So after calculating this, the telemark, we got the frequency. Number of students is the frequency. Basic principles for forming the group frequency tables. In this, we make the classes, right? Now, these are called classes 15 to 19, 20 to 24. The 15 to 19 is the first class, 20 to 24 second class, third class, fourth class, and so on, right? In this is called in the first class. First class is, what is first class? 15 to 19. In first class, the interval is 15 to 19. Interval is 15 to 90, right? We call lower limit is 15 and the upper limit is 19. Lower limit is 15 and the upper limit is 19. Similarly, for the second class, the lower limit is 20 and the upper limit is 24. Third, 20. The third 25 lower limit, 29 upper limit, and so on. Got it? Got it?
Yes, sir.
Now, what are the intervals on this? If we count in this 15, 16, 17, 18, 19, right? There are 5 marks coming in these, including 15 and 19, 5 marks, right? So this is the interval of 5, or we say the length of these interval is 5, or we say width is 5. Clear? Okay. Generally, what we do, see, in this example, we find that the minimum one is 15, maximum is 78, right? So generally, we have to find how many classes we need, or what are the intervals we have to find. So what we do, we find out the difference of maximum and minimum. Sorry. In this case, the maximum is 78, minimum is 15. We subtract 78 and 15. We got 63. We got 63. Right? So this difference is 63. And we assume that we need around 6 to 7 intervals, or 8 intervals or 9 intervals. We assume that we need 6 intervals, for example, 6 classes, right? 6 classes. So the difference is 63 we divide 63 by 6. It is approximately 10 point something. So what we do, we make the difference of 10. That is approximately height. Or we say approximately width. Right? So the first one is 15. So we make the difference of 10, that is 15 to 25. The next, again, difference of 10. We can also make 26 to this, or we say 25 to 35, then 35 to 45, and so on like this. Right? What I've told you, see. See. In this age is what 20 to 25, 25 to 30, 30 to 35, 45 to 40, and so on this. Right? And in this 19 to 24, 24 to 29, 29. So it's also similar. Come to this one. Now, what you have seen initially, what we have done, that if we take 20 to 25, then in the first class, the upper limit is 25. So in the next class, it should be like 26 to 30 or 31, whatever. Right? If there is difference of 5, then obviously if we increase this number 25 to 26, so 26 plus 5, that is 31. So 26 to 31, then 32 to this, and so on like this. Right? So this kind of series generally we do, and in the exam they show this type of series. Right? You have to find whatever the statistical result in this kind of series. Right? This is called the exclusive type. Exclusive type. See, we have seen that the upper limit is 25. In the next class, the lower limit is 25. Similarly, what we have seen, the upper limit of class is the lower limit of next class. Right? So this number is repeating in 2 classes. That means the upper limit 25, upper limit of first class is 25, and the lower limit of this is 25. So if 25 comes, we always take it in as a lower class. Right? For example, the age, if the age is 25, so we consider 25 in this series, in this class. If there is number 30, so we 30 consider in this third class, not in first class or second class. Right? So that number we always consider in the lower one, in the lower limit. Voila. Got it? So see in this illustration, 20 to 24, then 25 to 29, 30 to 34, and so on. Right? So in all, the difference is what? 4. But total width is including 20, 20, 21, 22, 23, 24. Right? So including 20 and 24, they are the 5 numbers or 5 kind of marks coming in this. right? So we can also change into these kind of, this is called the true class limit. This kind of, what we do for this, see, this is in the first class, the upper limit is 24 and the lower limit is 25 of the next class, right? The difference of 25 and 24, 25 and 24, or 30, 29, 35 or 34. In all the cases, the difference is 1. Difference is 1. So what we do, we make the half difference, half come to be the 0.5, right? So what we do, we subtract this 0.5 from the lower limit. We subtract 0.5 from the lower limit and add 0.5 to the upper limit. Subtract 20 from the lower limit and add 0.5 to upper limit. Similarly, the second class, if we minus 20 from this, we subtract 0.5 from 20, it comes to be 19.5. If we add 24.5 to 24, it comes to 24.5. So the limit becomes 19.5 to 24.5. In the similar way, the second, if we subtract 0.5, it becomes 24.5 and this becomes 29.5. So we subtract, we got this. In the similar way, we find out all these limit in true upper class or true lower class, right? Mid value, see, mid value we called class mark. See, in this lower limit plus upper limit divided by 2, we got the class mark. In this case, what is the class mark? If we add 20 and 24, we got 44. 44 divided by 2, that is 22, right? So the mid marks is 22, or we say class mark is 22. In the similar way, if the boundary is like this, answer is same. If we add these two, that is 24, same I got 44. If we add 19.5 and 24.5, cut 44, 44 divided by 2, 22. In this case, the class R should be same, right? So the midpoint is called the class mark. Open end classes. See, open end classes is like see, in this daily earning, in this, what we have seen in the second class, it is written that 101 to 200, third 201 to 100. But in 100, first class, they have written up to 100. They have not mentioned the lower limit of this class, right? In the similar way, also, somewhere is written not 700, 1 to 800. There are just like above 700, or in this case, below 100. So in this kind of series, we called it as a open end series. Okay. Open end series. Is it clear? Is it clear, sir? Yes, Shweta.
Yes, sir.
Now that one is clear, na? Inclusive or exclusive. Inclusive is this type, or exclusive, that is That is the lower limit and upper limit of the next class is very same, right? That is called exclusive type. Is that clear? Now frequency distribution. Okay. We wind up here, right? In the next class, we start the cumulative frequency distribution. Right? Is clear? Hello? Hello?
Yes, sir.
Right? Now, whatever we have done today, that is what is frequency distribution, how we write, how we make a table, right? Because this will help in the further calculation. What we do in the for the further, how we calculate the mean, median, and so on, right? So probably the next class I will start some more example practical questions regarding this mean, median, and all this. Or probably we will finish the graph and all, right? Okay, beta.
Okay, sir.
Okay then. Bye.